We have another example on the board. We have to find total admittance, because later on the problem is asking me to find the series equivalent circuit. I'm going to find first Z total, and after that I'm going to find Y total. So Z total is equal voltage source over I total. Okay? I don't have I total, but the current which is given, right, is nothing else, just my I total. If it's not specified that this is IR, IC, IL, this is your I total. So I have voltage source is equal 50 volts over I total 10 milliamps is equal 5 kiloohms. Our total impedance doesn't have angle. We have to find angle. So I have a formula for power factor which says power factor is equal cosine of angle theta. This is equal Z total over R. So I'm going to use this part of the formula to find angle theta. So theta is equal inverse cosine Z total over R. So I have inverse cosine, and I have Z total 5 kiloohms over R, which is equal 10 kiloohms, is equal 60 degrees. Someone is going to ask what angle I'm supposed to have. I mean positive or negative, because I know already the number, but I have to find the sign. So let's take a look what is given. X of C is greater than X of L. So it means that our angle is going to be positive. Anytime we are going to talk about the parallel RLC circuit, right? And X of C is going to have greater value than X of L, so angle is going to be always positive. Later on I'm going to explain why. So I have Z total equals 5 kiloohms and angle of 60 degrees. Now I can find Y total. Let me write this over here. So if Y total is 1 over Z total. So I have 1 divided by 5 kiloohms and angle of 60 degrees. This is equal 200 microsiemens and angle of negative 60 degrees. Okay, so this is my total admittance. IR is equal voltage across the resistor divided by resistance. Let me remind you that we are talking about the parallel circuit. So at this condition, voltage source is equal voltage across the resistor. This is equal voltage across the inductor, and this is also equal voltage across the capacitor, and this is equal 50 volts. Okay, so I'm going to have 50 volts divided by resistance 10 kiloohms. This is equal 5 milliamps. So this is the current which will go through the resistor. Next, I'm going to find the current which goes through the inductor. IL is equal voltage across the inductor over X of L. This is equal 50 volts over X of L, 2 kiloohms, and angle of 90 degrees. This is equal 25 milliamps and angle of negative 90 degrees. Okay, so this is the current which will go through the inductor. Next, we have I total given, right? So what we're supposed to find for this I total, we're supposed to find the angle. You're supposed to realize that I total is nothing else, just voltage source over Z total. Okay? Where voltage source, we prefer to have angle of 0 degrees, and we found that Z total has angle 60 degrees. Right? We know that I total has magnitude of 10 milliamps, and if you are going to subtract these two angles, because we're dividing two polar forms, anytime you divide polar forms you have to subtract the angles, you are going to end up with angle of negative 60 degrees. So this is my I total. So we have currents which go through resistor, inductor, and we have I total. We are missing the current which will go through the capacitor. So what I'm supposed to do? I'm supposed to use KCL. KCL says that I total is equal IR plus IL plus IC. You're supposed to solve this formula for IC and obtain IC equals I total minus IR and minus IL. So I have IC equals I total 10 milliamps and angle of negative 60 degrees minus IR, which is equal 5 milliamps, minus IL, which is equal 25 milliamps, and angle of negative 90 degrees. So IC is equal 16.34 milliamps and angle of 90 degrees. Anytime you are going to calculate the currents in the RLC parallel circuit, you're supposed to always look at the angles, right? Make sure that the resistor, right, is going to have current with angle of 0 degrees. Inductor is going to have angle negative 90 degrees for current, and IC is going to be with angle of 90 degrees. This is very important. So I found all currents. Next, I'm supposed to find the true power. P true is equal IR squared times resistance. We found that the current which goes through the resistor is equal 5 milliamps. We're supposed to raise this to the second power times resistance, which is equal 10 kilohms. Everything is equal 250 milliwatts. Okay, so this is the true power in the parallel circuit. Please notice that I use the formula for power, P is equal IR squared times R, because the problem is not telling me that voltage source is peak or peak to peak and the current is peak or peak to peak, so I assume that both of them are RMS. That's why I'm using this form, right, of the formula to find the power. Now we are going to find the total reactive power in the parallel circuit. Okay, so in order to find total reactive power, I'm going to find first total reactance in the parallel circuit. So I have X total is equal X of L times X of C over X of L plus X of C. Okay? These two components are in parallel. That's why I'm using the formula called product over the sum. This is equal. X of L is 2 kiloohms and angle of 90 degrees times X of C 3.06 kiloohms and angle of negative 90 degrees over 2 kiloohms and angle of 90 degrees plus 3.06 kiloohms and angle of negative 90 degrees. Everything is equal 5.77 kiloohms and angle of 90 degrees. Okay, so this is my total reactance in the parallel circuit. Now, please notice that X of L has value of 2 kiloohms and X of C has value of 3.06 kiloohms. So X of C is greater than X of L. And from this calculation, we get angle of 90 degrees, positive angle, right? So X of C is greater than X of L. That combination is going to give me positive angle. That's why Z total, right, which we obtained, right, was equal 5 kiloohms, right? And we found angle of 60 degrees, and we left this angle positive because combination of inductor and capacitor gave me positive angle. Okay, so one more time, anytime you are going to have parallel circuit and X of C is greater than X of L, your angle is going to be always positive. Okay, when we talk about the series circuit, it's going to be opposite. But if it comes to the parallel circuit, anytime X of C is greater than X of L, angle is going to be positive. Next, we're supposed to find the reactive power. So Q total is equal voltage source raised to the second power over X of T, right? XT, total reactance. So I have voltage source is equal 50 volts raised to the second power over Xt 5.77 kiloohms is equal 433.27 millivolt ampere reactive. Okay, so this is the total reactive power in my parallel circuit. Now we're supposed to find the power factor. Power factor is equal cosine of angle theta. So this is cosine of angle 60 degrees. This is equal 0.5, and I'm supposed to use word lag. Why? Because angle next to Z is positive, right? So it means that the current in this circuit is going to lag the voltage source, right, by 60 degrees. Next, we're supposed to find the series equivalent circuit. So we found already Z total, so I have to write Z total is equal 5 kiloohms an angle of 60 degrees and convert this to rectangular form, right? So this is equal 2.5 kiloohms plus J 4.33 coulombs, where the real part of my Z total is my resistance, and the imaginary part, because it's positive, this is nothing else, just X of Ls. Okay, this is the inductive reactance because the sign is positive. So I found Rs and X of S is nothing else, just XL of S, because before we couldn't guess if this is going to be inductor or capacitor. That's why we have just XS. But right now we know that this is going to be inductor. That's why we have XLS. Next, we're supposed to find the voltage across the resistor. So V RS is equal I total times RS, which is equal I total 10 milliamps and angle of negative 60 degrees times RS, which is equal 2.5 coulombs, equals 25 volts and angle of negative 60 degrees. Okay, so this is the voltage across the resistor. Now we're supposed to find the voltage across the inductor. So we have V Ls is equal I total times X of Ls. So this is equal 10 milliamps and angle of negative 60 degrees times XLS 4.33 coulombs and angle of 90 degrees. Everything is equal 43.3 volts and angle of 30 degrees. Okay, so this is the voltage across the inductor in my series equivalent circuit. Let me just remind you that the circuit is going to look like this. We have voltage source, we have resistor Rs, and we have inductor with the inductive reactance X of Ls equals 4.33 coulombs and Rs is equal 2.5 coulombs. Voltage source is equal 50 volts. Okay, so we found VRS, VLS. Next we're supposed to find the true power and reactive power. True power in the series equivalent circuit, PS, is equal I total raised to the second power times Rs. So we have I total 10 milliamps raised to the second power times Rs, which is equal 2.5 coulombs, is equal 250 milliwatts. Let me remind you that the true power in parallel circuit, right, we got 250 milliwatt also. Okay, so it means that up to this moment our calculations are correct. Next we're supposed to find the reactive power in the series equivalent circuit, QS. We know that this is going to be at this moment QLS is equal I total raised to the second power times XLS. So I have I total 10 milliamps raised to the second power times XLS, which we got 4.33 coulombs. So QLS, which is equal QS, is equal 433 millivolt ampere reactive. Let me remind you that the reactive power in the parallel circuit was equal, right? Was equal 433.27 millivolt ampere reactive. Okay, we call that Q total. So Q total in the series equivalent circuit is our QLS, and as you can see, these values are very close, so it means that we solve problem correctly.